Many great ideas start with a spark of inspiration, and this project is no exception. I drew the core idea and its nature from a balanced mix of sources that inspired me, starting with the flexibility and power of environments built in Unreal Engine, moving through the open world of Minecraft, and reaching the excitement and speed of games like Need for Speed, Most Wanted, and Forza Horizon. By blending these elements, I'm working to deliver a complete experience that combines creativity, freedom, and the joy of challenge in a practical and straightforward way. Press A and delete everything. Add a new plane by pressing Shift plus A, going to Mesh and selecting Plane. Scale it up by pressing S10 and pressing Enter. Add a new camera. G, Z, move up by 10. Set all rotation values to 0. Set the camera resolution width and height to 1024. Set the frame rate, FPS, to 60. Set the keyframe sync to frame dropping. Change the camera type to orthographic and set its ortho scale to 20 to prevent clipping. Fine, I think everything is okay. We can name the plane anything. You can call it texture, but it's better to name it normal. I think that's better, but let's stick with texture. There's no problem with that. Okay, there is nothing to worry about. I am just organizing things so they look good for you to understand. Here, I am switching to the normal viewport mode so that the image is ready for use in the actual render or material viewport. By going to Color Management, use the standard mode to avoid color issues. Switch to the Geometry Nodes tab, then, after making a few adjustments, create new geometry nodes. I will zoom in a little so that all the nodes we are going to use here are clear to you. The geometry nodes results will appear on the plane, and to make that clear to you, we will add a Distribute Points on Faces node. You will notice random points appearing on the face of the plane because it only contains one face. By pressing S, Y, then 0, we will remove the gap and make the nodes consistent with each other. After that, we will need to connect some meshes together. And to do that, we will place a Join Geometry node. After connecting the geometry output to the Join Geometry input, you will notice that both the original object and the object after the Distribute Points on Faces effect appear simultaneously. The reason for this is that we will create a mirror that reflects in all directions and surrounds the camera, so we can get rid of the problem where squares appear after applying the image in the shader nodes. Place a Join Geometry node, then press Ctrl plus G. We have now created a group node. I think it is very useful for organizing the workspace. I think we need to place a Set Position node in order to move the object using the offset input. We are moving the object by 2 meters along the x-axis. This, of course, will create the left side for the camera. Alright, reverse the direction to draw the right side for the camera. Press Shift-D to copy the nodes, X0, Y2 to get the top side of the camera. Reverse Y to get the bottom side of the camera. Now, we are creating the diagonal sides for the camera. It's simple and not complicated. It depends on both X and Y. It's simply 2, 2, then 2, -2, then -2, -2, and then -2, 2. And these are the sides that will appear here. Alright, after finishing the process of positioning the sides, you will notice that the nodes are starting to look a bit complex, but it is simple and there is no need to worry. We pull this a little bit back and down at the same time. We place this so it connects with the others, and we will do this somewhat simultaneously. Finally, connect the geometry output to the Join Geometry input. The result is before your eyes. Now, if you look closely here, you will notice that the particles are perfectly aligned with each other. This is currently looking very good. Let's head over to the Geometry Nodes workspace. Select all of these and press Ctrl+J to place them in a frame box. If you want to exit the group node mode or exit it in general, just press Tab. Alright, I think everything is fine now, and things are going perfectly. Let's name this node group Mirror. I think it's a suitable name for what it provides. Now, after doing that, select this node and press the same keys that created the node group, which is, of course, by pressing Ctrl+G. Try deleting these. We actually don't need them, but keep these because they aren't causing any problems. Press Ctrl+H. To temporarily hide the unnecessary extras, these points are a bit annoying and don't look great, so I suggest using instance on points. And that strange sudden disappearance is because there is no value connected to the geometry input of the instance on points node. Therefore, add a UV sphere and connect it to the geometry input. Adjust these values however you like, but I recommend copying these specific ones, as they will help maintain performance. Memory usage. If you want to get rid of the hardness of the shape and the sharp faces, place a Set Shade Smooth node right before the last node. You will notice a nice smoothness in the spheres. The spheres are strangely large and causing lag, so go to the group responsible for managing these particles. Resize the spheres by changing the radius value. Set the value to 0.02. This is much better for now. Exit this node group, and on the outside, increase the density value. You will notice the number of particles increasing gradually. Now, after returning, you will notice that the randomness of the points is good enough. After returning to the Geo workspace, I just want to make the nodes organized. The scale input is responsible for controlling the size of the instance within the geometry node space. I will make some minor adjustments. We will separate the scale vector using a combine XYZ node. Connect it, and you will notice that each value has a circle, which allows us to apply some mathematics here. For example, I placed a value node, so you can see the breadth of control. And now we are controlling the size of the circle by connecting the same value to both X and Y. Okay, that was just a test, so I advise you to delete it for now. Okay, to create variation in the size of the droplets, connect a random value node to the input for that point. Okay, you can now see the variation in sizes, which is somewhat good, but you can also adjust these values or change anything here so that it suits what you want. This, in reality, might take us closer to realism. Okay, the variation in positions and sizes is good, but there is a problem. The points look like holes. Therefore, just change the Z value to the lowest good and possible value. Or, you can leave them as holes if you want, because you can adjust anything later in the shader nodes. Everything is fine for now. Okay, now we want to control the movement of the instance. For that, just place a set position node. At the offset, specifically on the Z-axis, it is good for creating the motion of the points appearing on the surface, and this technique is essentially what gives your scene a dynamic, organic feel, as it mimics the natural process of condensation or liquid accumulation rather than static placement. The shape of the points doesn't look good from above, but that's okay. To control the Z-axis offset value, we connect it as usual with a combine XYZ node. I think if you look at video games like car racing games, you will notice that points disappear and then reappear automatically, sometimes in the same place, and to avoid complicating the tutorial, we now want to set some values that are default and automatic. So I am going to place a Scene Properties node. You will notice what that value does after going to the timeline editor. When we move this, we notice a sudden and mechanical rise in the points. And the bad thing is that they all rise at the same time, which is annoying because it doesn't simulate reality at all. To achieve this, place a math node and set its type to add. It is currently set to its default value. Then place a random value and connect it. This will give us the feeling of variation and a more natural look. But we currently need to make the effect centered on the surface, so we place a math node set to subtract, then connect the node to the input and set this value so that the points start rising from the bottom of the shape, thereby allowing the particles to appear in a more realistic way. But we also want the points to rise to a certain limit and then return back to the bottom. And for this to create a good, non-synchronized loop with the rest of the points, we need to use wrap. Okay, but to limit the point's motion, just change the min and max values to whatever you prefer. But it is best to set these values. Okay, after that, you will notice that it still seems like the points want to appear at the same time, and this doesn't make things look more realistic. So we must increase the random value max value a little, or even more, until you notice the synchronization between them has disappeared. Immediately after the set position node, place a realize instances node so that we can convert every instance into a mesh. Then, place another set position node. Then, place a noise texture. Place a vector math node after the noise texture output and set it to multiply. I meant subtract, not multiply. Change all values to 0.5. Place another vector math node set to multiply. x1, y1, z0. This looks bad. Add another vector math node, set its type to scale, and set the value to 0.01. That's look amazing. Just as the points appear, disappear in another place, and return. Now, select all those nodes by pressing SY0 to align them. Then press Ctrl+J to place them in a frame, and you can name them whatever you like by pressing F2. Press space to stop the animation. Press Tab to exit the node group. When I change the density now, the number of droplets on the surface changes, as you can see. Therefore, the higher the count, the better the effect, but we can make it lower for now. Okay, place a mesh to points node and set it to faces. We are doing this to create a unique path for every raindrop using curves. By centering each curve on its specific face, we ensure that each drop follows a precise, individual trajectory from the center of that single face. Then, place an instance on points node. After selecting both, press Ctrl+G again. Add an object info node. Then, after that, exit the geometry node's workspace entirely. Press Shift+A, then select curve. Name it whatever you want. Just remember its name well. In edit mode, delete everything, then select the curve pen tool. From this point to this one, we will start drawing gradually in a descending manner. Draw a large number of rain paths and make them very random, yet logical and realistic at the same time. And do not cross at least 3 camera-sized squares. Okay, go back to object mode, and here is the name of the curve, and we finish the path. Now go back to the geometry nodes, copy this again, align these nodes. Make these nodes more regular and organized. Then connect this to the geometry. Then choose your rain direction object. You will notice that the instance size is too large and inconsistent. So change it from absolute to relative, and that's what we want. Now, create a little workspace to make the project clearer and easier to manage. Place a curve to mesh node. Enable fill caps, and also add a curve circle node. Then, after some rerouting of the nodes, connect them together. We now have shapes that look like spaghetti. Make it 16 segment by pressing Shift+A. Add a trim curve node. The trim curve node allows you to control the start and end points of a curve by adjusting the start and end values, which range from 0 to 1. By pressing Shift plus A, add a resample curve node. Set any value in the count of the resample curve node. In the same way, add a set spline type node. Set it to Bezier. This will make the splines smoother. Now, we want to set up the radius controller, so add a set curve radius node. This will allow us later to control the radius of the tip of each curve, which is perfect for us. Click Set Trim Curve. Press Ctrl plus G to put in one node group. We are going to delete all of these. They are unnecessary. Go back out of the node group, and what you'll notice is that the workflow is now somewhat organized. Name this node group whatever you want, or name it the same as what I named it. I now want to get rid of these values, so press N. Okay, everything is fine now. Press Tab so we can control all the values. Delete them. Add a Scene Time node to define the start and end of the curve as a gradient so we can successfully sculpt the shape of the droplet. After that, connect it with them. I want to make the current setup look good so that it's easier for us later on. By pressing Shift plus A, place a math node and set the type to divide, and set the input value to 6. Place another math node in the same way. Okay, the setup looks like it was before, so change the type from add to subtract, so we can make the start lag behind the end by a certain value. That value represents the length of the droplet. Go to Edit, Preferences, Theme. Switch to the node editor to control it properly. Go to Noodle Curving, set a value to 0. The curve nodes are perfect and more readable right now. The curve animation is moving but not randomly. We need to fix this. They are also falling at the same time, which is somewhat bad, so we need to fix this immediately as well. Create a good workspace as usual. Place a math node. Add a random value node. Set the type to float and connect it with a math node. Set the value to 6. Now, as usual, we need a wrap node. Place it here and try changing the values a little bit. Add another random value node, and this one will control the length of each raindrop. After that, we will place another math node to further smooth out the shape's movement. This random value node is responsible for the variation in length of each raindrop on the surface. You are welcome to adjust the values according to your personal preference. Here, you need to swap the positions of the inputs so you can see the animation clearly, just as you intended. The movement now looks much more natural than before. Since we are still using cylinders, the goal is to refine their behavior so they feel like falling liquid rather than rigid objects. Now, select the Set Curve Radius node and press Ctrl plus G to group it into a new node group, so press N. Okay, everything is fine now. Add the Spline Parameter node to your setup. We do this to gain precise control over the radius of your raindrop along its entire length. By using the factor output, you can create a tapered, teardrop-like shape rather than a uniform, pipe-like cylinder. Now, add a Flute Curve node and place it between the Spline Parameter node and the Set Curve Radius node. Here is the float curve shape you should create. That is fantastic. I will now make some adjustments to make the final image a bit more realistic. Change your float curve shape and try to make it more realistic. Raindrops look more realistic now, but they still resemble sweat a little bit. To fix this, try reducing the diameter or the radius of the drop, and we will notice a big difference now. Great. And now we are starting to get closer to the end result we want to achieve. We place a Realize Instances node right before the last node. To make these raindrop objects tangible and realistic, add Set Position node. This offset helps us sculpt the rain to look more liquid. Now we need to place a noise texture. The rain looks dreamlike and weird. Set the Vector Math node to type Subtract and make all XYZ 0.5 value. Place a Vector Math node, set it to Multiply, and set the values to 1, 0.2, and 0. Place another Vector Math node, set it to Scale, and set its value to 0.08. Adjust the Noise Texture Scale to 3 to refine the surface detail, ensuring the procedural effect appears more structured and realistic, rather than overly distorted. If you find that a scale of 3 is still too soft or dreamy, increasing the Noise Texture Scale to 4 will create much finer, more frequent surface irregularities. This higher frequency helps the liquid displacement look tighter and less like a slow-motion blur. If you encounter any problems with the path, you can adjust it here. To change the path or position, and if you want to prevent the raindrops from overlapping, simply play around with the rain direction path. This will fix all the issues you are anticipating, but do not let the length of the rain exceed 3 of the previous grid squares. Okay, I mean what I said. I think we are currently finished with the work, and now we will have to connect this to the other one so we can see the final result. Name this node Rain Simulation, or any name you prefer. Thus, the situation has become a bit more logical. Name the other node that is located above this one Raindrop, because it contains stationary, static particles that are scattered at the same time. You will notice that the drops are falling below the raindrop particles. This is a bit strange and illogical, so we now need to scale the shape relative to the z-axis. And there is another strange and annoying error that makes the old rain appear above the new one, which is not correct. Therefore, we need to raise the rain simulation particles above the raindrop particles relative to the z-axis, so that it always remains below them and gives a realistic impression at all times. The raindrop particles are not entirely smooth, so I currently need to make them smoother. To do that, I have to go to the UV sphere and increase the number of rings in a structured and well-managed way, while simultaneously keeping memory usage in check. Okay, and now the shape of the rain is getting closer and closer to reality. We will solve the particle dispersion problem later, and we will make them fade away, but in a smart way that doesn't require much more work, so I don't make the video any longer than it already is. Make the shape of the rain simulation particles less sharp, and do not make them look like pits by reducing their size relative to the z-axis. Now we will need to increase the density a little, to about 200 up to 300 or 400, so that the falling becomes lighter, more varied, and better. This gives a more natural impression in reality. Just make sure that the render settings are good and match what I currently have so that we can render the images as an image sequence that is lightweight and efficient for the workflow. Now, define your TMP path. It is the location where the images are saved so that you can use them later in the shader nodes. Okay, after completing this procedure, I believe we have finished everything completely. Just keep in mind that you should only render the frames that you actually need for your presentation. Now, hit the render button. First of all, you need to select your image sequence. Open all video properties on the right. Move your image sequence node all the way up to the top. To achieve a professional visual effect using an image sequence in the node editor, duplicate your current tracker node by pressing Shift+D multiple times, offsetting each new track forward by 1 frame to create an advanced motion blur or temporal contrast effect. Always ensure your frame rate is set to 60 FPS for smooth playback, and lower the opacity value to 0.05 for the duplicated node so the layers blend seamlessly without making the image overly bright or saturated, resulting in a cohesive and deep cinematic look for your scene. Align the positions of all the tracks. Set an appropriate custom path for your files. Done. Finish everything by clicking on Render Result.